Good morning everyone. Today in this live lecture we shall discuss the numerical solution of a ordinary differential equation. Also we have to solve the problems based on the Picard's method. Actually this is the last but one part, that is a Picard's method. Then tomorrow we shall discuss the Taylor series and the problems based on the Taylor series. प्रेझेंटी मध्येच टाकू नका रे. प्रेझेंटी सर्वांनी मी जेव्हा सांगतो ना तेव्हाच प्रेझेंटी टाकायचं, म्हणजे त्यावेळेसचीच प्रेझेंटी कन्सिडर करू. मुलं प्रेझेंटी टाकून जात आहेत है ना. सो वी शॅल मूव टुवर्ड्स द प्रॉब्लेम्स बेस्ड ऑन द पिकार्ड्स मेथड. ॲक्च्युअली यू नो दॅट द सोल्युशन ऑफ द पिकार्ड्स मेथड अन इक्वेशन हे आपण पाहिलेलं आहे. अन इक्वेशन डिफरन्शियल इक्वेशन ऑफ द फॉर्म. डिफरन्शियल इक्वेशन मीन्स विच कंटेन्स द डेरिवेटिव्ह, which contains the derivative, so that will be the Picard's method. 1 minute. So we shall discuss this. Already we have discussed what is meant by numerical solution. In the Euler equation, the solution or approximations are given by y1 is equals to y0 plus delta y0. So already we have calculated. In the Picard's method, the approximations are given by u3 is equals to u3 of x is equals to y0 plus integral from x1 to x, sorry, x0 to x, f of x comma u2 of x dx. In this way we can write the general approximation un plus 1 of x is equals to y0 plus integral from x0 to x f of x comma un of x. Already we have discussed this. One problem which we also solved in the last lecture. Now today we shall discuss the next Picard's method examples. Okay. Now we shall move towards the example number 2 by the Picard's method. Use the Picard method. Use the Picard method of a successive approximation to evaluate dy by dx equals to approximation to dy by dx equals to x plus y with boundary condition y is equals to 1 when x is equals to 0. ब्रॅकेट मध्ये घ्या. कंप्यूट थ्री इटरेशन्स only and also check the result with exact value. That means we have to solve this differential equation by the different solution of the differential equation method, which we have studied in the B.Sc. second year. And by using that B.Sc. second year's method, we have to calculate the value of dy by dx and calculate the direct value also. Okay. Now, ठीक है, now we shall move towards the solution. Given differential equation is dy by dx equals to, we can write this differential equation is x plus y. Suppose this is equation number 1. This is the differential equation. Now the boundary conditions y is equals to 1 when x is equals to 0, means x0 is 0. So the first approximation is already given. First approximation means by using this boundary condition. The first approximation is given by u1 of x is equals to 1. That means the value of y. चला रे सेकंड अप्रॉक्सिमेशन चा फॉर्म्युला सांगा बरं सर्वांनी. What is the formula for the second approximation? Now you tell me if the formula for the second approximation. काय तो मी अटेंडन्स जेव्हा विद्यार्थ्यांना टाका म्हटलं तेव्हाच अटेंडन्स टाकायचं, मध्ये मध्ये अटेंडन्स कोणीच टाकायची नाही. What is the formula for the second approximation? For the second approximation, how we can write u2 of x which is equals to काय formula y0 plus integral from x0 to x f of x comma u1 of x dx. This is the second approximation which is given by the Picard's method. Here we have to replace y by u1 of x. u1 of x means the y. So we can write this. So u2 of x is equals to y0 is initial value, that is 1, plus integral from x0 means 0 to variable value x. Initial condition means actually that are the x0, y0. That are the x0, y0. So it will be the first value. u1 of x means x0 plus y0 plus 1 means 1. So y1 first approximation म्हणजेच y1. y1 ची व्हॅल्यू काय असते 1 आहे. So we can write this f of f of x comma u1 means 1, u1 of x means 1 dx. आता f of x comma y means x plus y. इथं वाटलं तर लिहू what is mean by f of x comma y, which will be the f of x comma y, and suppose this is equation number 1. So we can write 1 plus integral from 0 to x f of x comma y means x plus 1 dx. So calculate this integral. आता integral calculate करा, that is u2 of x is equals to 1 plus काय येतं integral x plus 1 चं integral, that is x square by 2 plus x. Very good. 0 to x. Okay. So we can write x square by 2 plus x plus 1. This is u2 of x. This is the second. Now we can write the third approximation. The third approximation is u3 of x, which will be y0 plus integral from x0 to x f of x comma u2 of x dx. That means y0 means 1 plus integral from 0 to x f of x आणि y म्हणजे ती टर्म ठेवायची, u म्हणजेच y, y म्हणजे u2 म्हणजे ही टर्म येणार. So we can write f of x comma x square by 2 plus x plus 1 dx. That means in place of y put x square by 2 plus x plus 1. So our function is x plus y. Our function is x plus y. Y means this. So we can write 1 plus integral from 0 to x plus f of x comma y means x plus y means x square by 2 plus x plus 1 dx. This is x plus y. See this, f of x comma y means x plus y. x as it is, y means again we have to put u2. u2 म्हणजे y ठेवावं लागेल. So integration of u3 of x is equals to 1 plus integral from 0 to x, we can write x square by 2 plus 2x plus 1 dx. Now we have to calculate the integral of this function. आता याचं इंटिग्रल कॅल्क्युलेट करा. So 1 plus याचं इंटिग्रल काय येतं पहा, x क्यूब बाय 6. मला सांगा बरं 2x चं इंटिग्रेशन काय येतं, 2x चं 2i इज इट इज x 2i is it is x square by 2 plus 1 चा x from 0 to x. So we can write the upper limit and lower limit. If we put the upper limit and lower limit, so we can write the upper limit and lower limit, that is 1 plus x cube by 6 plus x square plus x. Okay, so u3 of x is equals to x raised to 3 divided by 6 plus x square plus x plus 1. This is the third approximation. किती approximation calculate करा म्हटले तरी पहा. In the problem we have given compute the 3 iterations, only the 3 iteration. So 3 approximation. You can calculate also 4th approximation. याचं तुम्ही 4th operation calculate करू शकता. मी calculate करून नाही दाखवणार, फक्त माहित राहावं म्हणून सांगतो. Similarly गरज नाही आहे त्याची, we have to calculate only 3 operation. Similarly u4 of x is equals to y0 plus integral from x0 to x. So f of x comma u3 of x dx. Is it okay? So we can write u4 of x, which is equals to 1 plus integral from 0 to x, x plus, in place of y we have to put this value 1 by x cube by 6 plus x plus 1 x square plus x plus 1 dx. आणि कॅल्क्युलेट करा, याचं फायनल आन्सर येतं पहा x raised to 4 by 24 plus x cube by 3 plus x square plus x plus 1. This is the u4 of x. But we can calculate the value u4 of x. Now when x is equals to 0.1, we can put the value of x is equals to 0.1. Then we have u4 of x is equals to, आता u4 ची गरजच नाही आहे, आपण u4 of x काढू. ठीक आहे, u4 of x is equals to 0.1 raised to 4 by 24, 0.1 raised to q by 3 plus 0.1 square by 1 square. Okay, there is no denominator, that is 1 plus 0.1 plus 1. So it will be, आता याचं कॅल्क्युलेशन करा, मी कॅल्क्युलेशन करून ठेवलेलं आहे. सो 1.1103 हा u when x is equals to 0.1, if we put x is equals to 0.2, when x is equals to 0.2, then u4 of x, हे कॅल्क्युलेशन करा तुम्ही, घरी करायचे हे 0.4, that is u4 of 0.2 which will be 1.2427. आता हे आपल्याला एक्झॅक्ट व्हॅल्यू शीट कम्पेअर करायचे आहे. एवढा प्रॉब्लेम गरज आहे, इथपर्यंत सफिशियंट आहे. पण एक्झाममध्ये जर विचारलं तर लक्षात ठेवा, काहीच विचारत नाही तेवढं. एक्झाममध्ये जर विचारलं तर फक्त आपल्याला U1, U2, U3 इथपर्यंतच कॅल्क्युलेट करायचे आहे. बाकीचा पार्ट एक्झाममध्ये विचारत नाही आहे. त्यामुळं मी एक्स्ट्रा पार्ट आपल्याला एक्झॅक्ट व्हॅल्यूसाठी कॅल्क्युलेट करून दिलेला आहे. ॲक्च्युअली इन द एक्झाम वी कॅन आस्क ओनली द 3 इटरेशन, दॅट इज U3 of x is equals to this. This is the last answer, but you can similarly calculate U4, U5 in this way. Okay. So similarly you can calculate U4, U5 in this way. आता याला परत एक्झॅक्ट व्हॅल्यूशी कंपेअर करायचे आहे. Now to find the exact solution, कंपेअर करायचं ना. dy by dx equals to x plus y. आता हे तुम्हाला झालेलं आहे. सोल्युशन कॅल्क्युलेट करायची मेथड झालेली आहे. यू नो दॅट द सोल्युशन वी कॅन कॅल्क्युलेट धिस बाय द एक्झॅक्ट मेथड. याचं सोल्युशन कॅल्क्युलेट करायची मेथड झालेलं आहे. इंटिग्रेटिंग फॅक्टर काय? इंटिग्रेटिंग फॅक्टर इज इक्वल्स टू इंटिग्रेशन ऑफ e raised to minus integrate e raised to minus x dx. So x dy, so we can write it as e raised to minus x. So the solution is y into integrating factor. हे आठवतंय का पहा, इन इंटिग्रेशन x into integrating factor dx plus c. So y into e raised to minus x. You have completed this process in the B.Sc. second year. हे तुम्हाला B.Sc. second year ला झालेलं आहे. बरोबर आहे का रे स्टुडंट्स? इंटिग्रेशन ऑफ x into e raised to minus x dx plus c. आता इंटिग्रेशन बाय पार्ट वापरा. y into e raised to minus x. फर्स्ट as it is. बरोबर आहे का? इंटिग्रेशन ऑफ सेकंड e raised to minus x चं इंटिग्रेशन e raised to minus x into minus 1. Minus in integration derivative of first one integration of second e raised to minus x into minus 1 dx plus c. So y into e raised to minus x is equals to minus x e raised to minus x plus e raised to पुन्हा minus x चं इंटिग्रेशन येतं e raised to minus x into minus 1 plus c. आता e raised to minus x न डिवाइड करा. e raised to minus x न डिवाइड केल्यानंतर काय येईल पहा. डिवाइड केल्यानंतर मायनस मायनस इथं काय होतं पहा. आठवते का तुम्हाला रे स्टुडंट्स? हा, डेरिवेटिव ऑफ फर्स्ट x इंटिग्रेशन ऑफ सेकंड e raised to minus x चं इंटिग्रेशन e raised to minus x upon minus 1. minus 1 म्हणजे प्लस 1 होईल ना. हा, म्हणजे काय येईल पहा. पुन्हा ह्याचं इंटिग्रेशन म्हणजे इट विल बी प्लस. ओके, डबल इंटिग्रेशन प्लस येतो. हा, ठीक आहे. सो इट विल बी मग y इज इक्वल्स टू फायनल आन्सर येतं x minus 1 plus c into e raised to x. This is the required solution. आता कॅल्क्युलेट करा. when x is equals to 0.1, therefore y is equals to y is equals to 3 into e raised to c ची व्हॅल्यू काढा. when x is equals to 1, पर्टिक्युलर सोल्युशन काढायचे. 1 मिनिट. when x is equals to 0, when x is equals to 0, y is equals to 1. मग x is equals to 0 ठेवा, y is equals to 1 ठेवा. मग c ची व्हॅल्यू, c will be 2, then c will be 2. बरोबर आहे का? चेक करा. c ची व्हॅल्यू 2 येते. So required solution is y is equals to minus x हा एक मिनिट इथं मायनस एक्स -1 it will be -1 e raised to minus x into पुन्हा इंटिग्रेशन इथं -1 पुन्हा डबल मायनस येईल हा सो इथं मायनस आहे हा मायनस so y is equals to the required solution is minus x minus 1 plus 2 into e raised to x हा minus x आहे पण हे चेक करा तुम्ही so therefore now for x is equals to 0.1 therefore y is equals to minus 0.1 minus 1 plus 2 into e raised to 0.1 that will be 1.1103 so we can compare this with the solution y is equals to 0.1 1.1103 similarly we can calculate also for y is equals to 0.2 that is y of 0.2 minus 0.2 minus 1 plus 2 e raised to 0.2 it will be 1.2428 so compare these value to the approximations fourth approximation मध्ये compare करा म्हणजे जवळपास सेम येते it will be the equal so this completes the problem अशा पद्धतीने हा प्रॉब्लेम आपण कंप्लीट करू शकतो ओके so this is called as a Picard's method आता Picard's मेथडचं एक होमवर्क सुद्धा करू शकता मी होमवर्क तुम्हाला शेवटी देईन now we shall move towards the second value of the Picard's method okay so second now we shall move Picard method for solving first order first order simultaneous equation simultaneous equations such as dy by dx which is equals to f of x comma y comma z and dz by dx which is equals to g of x comma y comma z. That means dy by dx is a function of x comma y comma z and dz by dx is equals to function of g of x comma y comma z. Then how to solve these equations? By using a Picard's method we shall discuss one example. See this. By using this example we can find the solution of by using a Picard's method. See here, find the approximate y and z, find the approximate values of y and z using a Picard method. Using the Picard's method for the particular solution of dy by dx equals to x plus z and dz by dx which is equals to x minus y square. Now our aim is to find out the solution, that is a solution of this first equation dy by dx is y and solution of a second equation dz by dx is z by using the Picard's method, and we have given the condition satisfying satisfying y is equals to 2, z is equals to 1 when x is equals to 0. We have given the initial condition. When x is equals to 0, then y is equals to 2 and z is equals to 1. Then we have to find out the approximate value of y and approximate value of z by using the Picard's method. These are the simultaneous differential equations, okay. So we have to solve this by the Picard's method, okay. हे सुद्धा थोडं इम्पॉर्टंट आहे, महत्त्वाचं आहे, तुम्हाला लक्षात यायला पाहिजे, इम्पॉर्टंट. हा ठीक आहे. Now here given differential equations are which are those dy by dx which is equals to x plus काय दिलं रे, x plus z. We can denote it as a f of x comma y comma z. Suppose this is 1 and dz by dx which is equals to x minus y square which is denoted by g of x comma y comma z. Suppose this is equation second. Also we have given the initial condition x0 is equals to 0, then y0 is equals to 2, z0 is equals to 1. These are the initial conditions which we have also given in this problem. Now our aim is to find out the approximate value of y and approximate value of z by using the Picard's method. Now you know that the first approximation, now we can use the first approximation. For the first approximation 1 टाकू त्याला. For the first approximation this is suppose 1. We have to write y1 is equals to y1 म्हणा किंवा u1 of x, काही अडचण नाही. y1 is equals to y0 plus integral of x0 to x f of x comma x0 comma f of x comma u1 of x असं असतं. u1 of x u2 of y अशा पद्धतीने लिहू शकतो. So it will be y0 comma z0 dx. Okay, so y1 is equals to, you can write also u1, याला u1 सुद्धा लिहिता येतं. y0 means 2 इंटिग्रल फ्रॉम x0 ची व्हॅल्यू किती आहे रे स्टुडंट सांगा. x0 ची व्हॅल्यू 0 to x f of x comma y0 means 2, z0 means 1 into dx. आता काय करणार. Now you have to put in the function f, replace x as it is x, replace y as 2, z as 1. काय करणार तुम्ही आता. f या फंक्शन मध्ये म्हणजे इक्वेशन 1 मध्ये f of x comma y comma z is x plus z. But in this case z is 1, y is 2, x as it is. So we can write y1 is equals to, you note that in the Picard's method u1 of x also denoted by y1. This is the first approximation. u2 of x also we can denote. असं काही नाही. या Picard's method मध्ये हे जे y3 दाखवता येतं. So y3 यालाच तुम्ही असं सुद्धा लिहू शकता yn plus 1. Picard's method मध्ये y2 लाच आपण असं सुद्धा लिहू शकतो. y2 means u2 of x. There is no problem. Okay, so we can write this. हे इथं थोडं इंटिग्रेशन कॅल्क्युलेट करा. हे इंटिग्रेशन परत येतं पहा. काय येतं डबल पहा तुम्ही, कॅल्क्युलेट करा, सोल्युशन येऊन जातं इथं. हे इंटिग्रेशन चेक करा. Okay, y1 is equals to 2 into 2 plus integral of 0 to x. आता f मध्ये पहा, in place of f put x is x, y is 2, z is 1. f of x comma y comma z is x plus z, z is 1. So we can write x plus 1 dx. चला रे आता integration सांगा, what is the integration of x and what is the integration of 1 with respect to x? 2 plus, okay, Gautam Kumar, okay, I shall explain in the Hindi also. Okay, now this is the Picard's method. This is a particular method for solving the first order simultaneous equation, simultaneous differential equation. First is dy by dx is equals to f of x comma y comma z, dz by dx, which is f of g of x comma y comma z. Then how to solve this differential equation? Such types of a differential equation simultaneously we have given one example. By using this example you will get the solution method of simultaneous differential equation. Okay, now see this. Now according to the given condition we have considered this is f of x comma y, first differential equation, second g of x comma y comma z. Now replace this, put this value. Okay, आता कसं करता येईल, in f of x comma 2 comma 1 replace the value x as it is and z means 1, so we get x plus 1. Now integration of this is x square by 2 plus 1 integration x from 0 to x. Is it okay? So we can write x square by 2 plus x plus 2. Suppose this is a y1. We consider this as a equation number 3. Now here we can calculate y1 by using a first approximation. We can calculate yn by using a first differential equation dy by dx. Similarly, the first approximation is used to find the value of z1 by using a second differential equation. So also z1, now same process which we have to use, we have calculated yn in this way. Y1 can be calculated by using the first differential equation dy by dx. Similarly, we can calculate z1. This is the first approximation for second differential equation. मग z1 साठी फॉर्म्युला लिहू, z0 प्लस इंटिग्रल फ्रॉम, आता z1 साठी सुद्धा सेम फॉर्म्युला लिहायचे आहे. See this, dz by dx means z is a function derivative of z with respect to x. So we have to write its integral equation in terms of x. आप differential यहाँ पे देखो, so we have to write the corresponding integral equation for z which is in terms of x. So we can write z1 is equals to z0 plus integral from 0 to x, x0 to x. Okay, आता इथं z साठी थोडं विचार करा तुम्हाला. z साठी z is expressed in terms of g. पहा इथं z is expressed in terms of g. We have to write g of x comma y0 comma z0. That means the same process for the first approximation which we have used for y1, you have to use for z1. So we can write this side z0. What is the value of z0 according to the initial condition? z0 is 1 plus integration of x0 is 0 x g of x comma y0 means 2, z0 means 1 dx. Okay, now put this value in place of g, put x as it is, in place of y put 2, in place of z1. So we get g of x comma 2 comma 1. See this, from this g of x comma 2 comma 1, in place of y we have to put काय येईल मग x minus 2 square. Okay, So Z1 is equals to 1 plus integral of 0 to x minus y means 2. Y actually g कसा आहे पहा, g means x minus y square, y means 2, so we can write 2 square means 4 dx. Now you tell me the integration. 1 काय रे, 1 काय म्हणतात तुम्ही, ओके नो प्रॉब्लेम. हां कॅल्क्युलेट करा आता इंटिग्रेशन. सो 1 प्लस x इंटिग्रेशन x स्क्वेअर बाय 2 minus 4x from 0 to x. So we can write x square by 2 minus 4x plus 1. This is a Z1. Students, okay, we can write this as a, suppose 3, 4. These two equations are for first approximation. By using a first approximation, we can write y1. Also, we can write z1. Now, we have to calculate the second approximation. So, now for second approximation, now how we can write the second approximation for y? First of all, we have to calculate the second approximation for y, then we can calculate for z. Second approximation for y is y2 is equals to y0 plus integral from x0 to x f of x comma y1 comma z1 dx. So we can write y2 is equals to y0 plus integral from x0 to x f of x comma y1 comma z1. Is it okay? So y0 means fixed, that is a y0 is a fix, that is 2, plus integral from 0 to x integral of, आता f of x1 comma z1 आहे, f of x comma y comma z is x plus z आहे, f of x comma y comma z means x plus z, but we have to calculate f of x comma y1 comma z, so we can write x plus z1 into dx, because you know that, because we know that f of x comma y1 y comma z, it will be x plus z. So we can write f of x comma y1 comma z1 means x plus z1. So we can put x plus z1, but we know that the value of z1, आता इथं आपल्याला व्हॅल्यू माहित आहे z1 ची, z1 ची व्हॅल्यू किती आहे, so we can put the value. So y2 is equals to 2 plus integral from x0 to x, x0 means 0, to x, okay, x size it is, put the value of z, x plus z means what, x square by 2 minus 4x plus 1 dx. चला ठीक आहे, आता याचं इंटिग्रेशन घ्या रे स्टुडंट्स. y2 is equals to 2 plus integral from 0 to x, x square by 2. Now minus 4x plus x, we can write this as a minus 3x plus 1 dx. Now calculate this integral 2 plus, now what is the integration of x square? Now you tell me student, x square च integration x cube by 4, sorry, x cube by 3, 3 into 2 means 6, x cube by 6 minus 3 x square by 2 plus x over the limit 0 to x, that means the same function we can write, upper limit leva, that is x raised to 6 by 6 minus, sorry, x raised to 3 by 6 means 3x square by 2 plus x plus 2. This is a y2. This is the second approximation of required function, that is y2. Also we can find the second approximation for second simultaneous equation z2. dz by dx आहे ना. There are two different equations, so we can write this second approximation also. Is it okay? Also z2 is equals to काय लिहावं लागेल, z0 plus integral from x0 to x g of, how we can write student, g of x comma y1 comma z1 dx. Same process we have to use for, this is for y, now we can use for z. Okay, so calculate this, then we will get the result. याच्यावरून आपण रिझल्ट लिहू शकतो. z0, what is the value of z0? Initial condition according to the given initial condition 1 plus integral of x0 means x to x g of x comma, see this, x comma, this is x comma y1 comma z1. What is the value of g? See this, g means x minus y square, but we have replaced y1 square. Very good, Neeraj Parangsale, very good. So x minus y1 square dx. So 1 plus integral from 0 to x, x minus, put this value of y1. आता तुम्हाला y1 ची व्हॅल्यू ठेवावी लागेल. What is the value of y1? We have to check. X square by 2 plus x plus 2. X square by 2 plus x plus 2 bracket square dx. Now here we have to solve this by using the formula a plus b plus c bracket square. Who can tell me the expansion formula for a plus b plus c bracket square? And then we have to multiply by y, because this is the value of y1. मग तुम्हाला अगोदर ब्रॅकेट स्क्वेअरचा फॉर्म्युला वापरावा लागेल आणि मग मल्टिप्लाय करावं लागेल. सो 1 प्लस इंटिग्रल फ्रॉम 0 टू x x minus, okay, now use a square plus b square plus c square plus 2ab plus 2bc plus 2ac by using this. So a square means x raised to 4 by 4, b square means x square plus c square means 4 plus 2ab means x cube plus 2bc means 4x plus 2ac. बराबर है क्या स्टूडेंट? पहा 2ac means x square, okay, capital bracket close dx. Now multiply by minus this, then we will get 1 plus integral from 0 to x x minus x raised to 4 by 4 minus 2x square 2x square. Very good, Pranit Mule, very nice. 2x square, we shall write first x cube minus x cube minus 2x square plus minus 4x minus 4. Is it okay? Dx. Now you can calculate the integral of each term. You can calculate the integral of each term. हे x आणि हे minus 4x म्हणजे minus 3x होतो. So you can calculate integral of each term. So z2 is equals to 1 plus integral from 0 to x. It will be x raised to minus 4 by 4 minus x cube minus, we can write this as 2x square. Now this minus 4x minus x means we shall write minus 3x. Again the last term is minus 4. Now calculate this. z2 is equals to 1 minus, हे चेक करा रे, लास्ट टर्म 2x स्क्वेअर येते का? लास्ट टर्म, हाँ yes 2x square 2 into okay 2x square. Is it okay? 2x square plus x square means it will be 3x square. Okay, right, very good. Kon hai Vaishnavi, very nice. You have corrected that answer. Last term will be 2x square. So this 2x square and this x square means minus 3x square. Is it okay? So I shall write this minus 3x square. Now take the integration. X raised to 4 चा integration काय येतो? X raised to 5 by 20 minus x cube चा integration x raised to 3 by x raised to 4 by 4 minus 3x cube by 3 means x cube minus 3x square by 2 minus 4x over the limit zero to x. So the final answer Z2 is equals to, we can write minus x raised to 5 by 20 minus x raised to 4 by 4 minus x cube minus 3x square by 2 minus 4x plus 1. Thus we can obtain the second iteration. This is the process. See this is the process for finding the values of y and z in the approximation method by the Picard's method. By the Picard's method, and thus we can obtain the third operation, fourth operation, whatever may be. बस झाले. आता हे दो, this is the second approximation we can obtain. लक्षात आलं का रे? या पद्धतीने second approximation तुम्ही घेऊ शकता. Thus we can find the second approximation of the by using the Picard's method. Okay? तर आता याच्यावरचे मी होमवर्क देतो, तुम्हाला होमवर्क तुम्ही सॉल्व करा. ओके, नाउ होमवर्क. See this homework. First, approximate value of x and z by the Picard's method. By the Picard's method, that is dy by dx equals to x plus y comma dz by dx equals to x square minus y square when x is equals to 0, then y is equals to 1, z is equals to 1. Up to, see this, we have to take two iterations. We have to take two iterations, two approximation only. Second problem same hai, dy by dx equals to, we can calculate this. So dy by dx equals to, एक मिनट, y minus z. Okay, ठीक है. You can write dy by dx is equals to x plus y plus z, and dz by dx equals to x minus y minus z when x is equals to 0, y is equals to 1, z is equals to 1. इज इट ओके? तर या पद्धतीनं सॉल्व करा, या पद्धतीनं सोल्युशन निघेल तुमचं. ठीक आहे. ओके, हे दोन सॉल्व करा. आणि दुसरा जो आहे बाय द पिकॉर्ड्स अप्रॉक्सिमेशन, सक्सेसिव्ह अप्रॉक्सिमेशन, यूज पिकॉर्ड्स successive approximation for dy by dx equals to x minus y when x is equals to 0, y is equals to 1. हे पूर्वीचा जो प्रॉब्लेम केलाय ना त्याच्याप्रमाणे करायचं. u1 किंवा y1 कसंही वापरायला चालतो. So you can calculate this problem also. याचे 3 अप्रॉक्सिमेशन घ्या, अप टू 3. फर्स्ट आणि सेकंड चे प्रॉब्लेम 2 अप्रॉक्सिमेशन घ्या, थर्ड चा 3 अप्रॉक्सिमेशन घ्या. So you can calculate this. Okay. Fourth problem, dy by dx equals to x plus y square when y is equals to 0, when x is equals to 1. Same we have to use the Picard method. Dy by dx equals to y minus x square y is equals to 1 when x is equals to 0. And 3 approximation kara. We have to use 3 approximations. We have to use 3 approximation. Okay. काय म्हणता रे स्टुडंट्स? इंटिग्रल ट्रान्सफॉर्मेशन. ठीक आहे, तुम्ही काय करा, सर्वजण जे लातूरला राहतात ना त्यांनी सोमवारी कॉलेजमध्ये या. तुम्हाला मी ह्याचं इंटिग्रल ट्रान्सफॉर्मचं मेथड सांगतो. कोण घेणार आहे काय नाही ते सविस्तर सांगतो. सर्वजण लातूरमध्ये जे जे राहतात ना, ते लातूरमध्ये जे जे स्टुडंट राहतात त्यांनी काय करा, लातूरमध्ये जे राहतात ना त्यांनी या. इंटिग्रल ट्रान्सफॉर्म गायकवाड सरांना सांगितलं होतं पण घेतले नाहीत वाटतं. तुमचे सारखे तेच प्रॉब्लेम यायला लागलेत. गायकवाड सर घेत नाहीत का रे इंटिग्रल ट्रान्सफॉर्म? स्टुडंट्स, इंटिग्रल ट्रान्सफॉर्म गायकवाड सरांनी सुरू केलं नाही का? सुरू केलं नसेल तर आपण दुसऱ्याला देऊ, कारण तुमचं वर्ष वाया नाही जायला पाहिजे. आपण दुसऱ्याला देऊ, काय अडचण नाही. काय म्हणतात श्रद्धा जाधव, आश्रिया गोरटे, जान्हवी ढगे? ठीक आहे, आणखी सुरू नाही केलं का सांगा. सुरू नाही केलं असेल तर आपण दुसऱ्याला सोमवारपासून लागलीच दुसऱ्याला देऊ. नेक्स्ट वी शॅल डिमूव टुवर्ड्स. ओके, आता नेक्स्ट चौथा, dy by dx which is equals to x comma dz by dx which is equals to x cube y plus x cube z when x is equals to 0, y is equals to 1, z is equals to 1 by 2. Z is equals to 1 by 2. Okay. हाँ ओके ओके, मी सांगतो, देतो दुसरे. ठीक आहे, मी दुसरे सर देतो, काय अडचण नाही. ठीक आहे, हे प्रॉब्लेम आता खूप मोठे प्रॉब्लेम आहेत, वेळ लागला तर चालेल. मी आता यातला आपला लास्ट पार्ट राहिला टेलर्स थेरमचा, तो आपण उद्याला घेऊ. याचे सर्वच्या सर्व होमवर्क मला ग्रुपवर, सी दी स्टुडंट्स, ऑल दीज होमवर्क्स यू मस्ट सेंड ऑन द ग्रुप. इथं मात्र 2 इटरेशन करायचे, फक्त 2 अप्रॉक्सिमेशन. 6व्याला किती करायचं? 2 अप्रॉक्सिमेशन्स. सहाव्याला फक्त 2 अप्रॉक्सिमेशन करा. ओके, सर्वजण आता काय करा, ठीक आहे. नाउ वी शॅल स्टॉप हिअर. जान्हवी डगे, सर्वांनी हे होमवर्क करून पाठवा, ठीक आहे. नाउ वी शॅल स्टॉप हिअर. यस, ठीक आहे. मी सोमवारपासून तुम्हाला दुसरे टीचर देतो.